Swayam Prabha. Digital India. Educated India.
Hello again. In the last lecture, we spoke about the goal of the natural language processing. We saw what type of corpus that we need ideally in order to perform some natural language processing, and then what kind of application that we could develop when we have a corpus for the training purpose and so on and so forth. Okay. So, in this lecture, we are going to continue to work on the same, but we are going to dive deeper into what kind of terminologies, what kind of techniques that we are going to be using in order to perform some operations on the corpus. So, the first one is going to be incident matrix. So, I am going to give a little bit of theory first before we go into the details of what incident matrix with respect to a corpus mean. Okay. So, I am going to read out what is there in the slide right now. This is the definition of the incident matrix. Let G be a graph with n vertices and m edges. Then the incident matrix of size n by m is defined by the relationship xij is equal to 1 if there is an edge connecting I and j. It is 0 otherwise. So, this is also called as vertex edge incident matrix and is denoted by capital X capital G. Okay. So, this is going to be fundamental to certain operations in the corpus. So, we need to know a little bit about this before we dive deeper into the corpus representation of this. A graphical representation of the same definition is given here as an example. So, we have 4 edges and 4 vertices 1, 2, 3, 4. And there are edges E1, E2, E3, E4 here, right. So, what we have marked here is for E1 edge it connects 1 and 2. So, you will see E1 having a value of 1, 2. So, if you go to the 3 and 4, edge is not related to that. So, we have a 0 here, right. So, in the same fashion if you look at E2, it connects 1 and 3. So, you have a 1 marked for this vertex and this. So, in the same fashion if you look at E3 and E4, E4 is connecting the vertex 1 and 4, right, and E4 is connecting the vertex 3 and 4. Okay. So, now we know what is incident matrix, and let us see how we can translate this into our corpus. So, now what I am doing here is I have taken the plays, Shakespeare plays in particular as my corpus, and I have listed the play names here. Okay. And I have used a tokenization algorithm and found all the words in all the plays that I have listed here. So, they are listed along this. Okay. So, every word is listed in this. So, let us take only certain names that we know very well and then see how we can fill this up. So, when I take the word Antony, then I want to find out whether this name appears in all the plays. So, here the one that we have marked means the name has appeared in Antony and Cleopatra. So, the name again appeared in Julius Caesar. It does not appear in the Tempest, Hamlet and Othello. In the same fashion, for every word we fill in the matrix as ones and zeros. So, what do you see in this? You see lots of ones and lots of zeros. Okay. So, in a corpus of size of internet size, and considering you have about 1 trillion documents which are listed as in the place and the vocabulary listed along this axis, and not all words appear in every document, correct. So, that means the words that appear in document would be represented by 1, and in those documents where it does not appear, they are all represented by 0. That means if you have a 1 billion word vocabulary and 1 trillion documents, most of the cells would be 0. That means we have a sparse matrix there. So, that is the situation when you consider a huge corpus. So, in this case we have taken a very small corpus. So, we will find still many zeros in this matrix as well. So, again if you look at this term document binary incident matrix, what this is you called as a term and this is your document. Okay. So, we have filled in the document with ones and zeros whenever the word or term is found in that particular document. Again we do this for the second one, third one, fourth one, and how many ever documents that you have, you do the same operation. So, again taking the idea of what we described in the theory, we have created a matrix which is called as a term document binary incident matrix. Okay. So, this is how you create this. So, if you want to find out how this is done, you want to know more about this, you may want to go to the reference that I have given in the slide, that reference number 3. Okay. So, the reference is available at the end of this presentation. So, we know this, right. I also want to explain this word term. Term here means a word or a combination of words, or sometimes could be 3. A phrase represents a term, a word also can represent a term. So, I would use this word interchangeably in terms of word or term and throughout the lecture. Okay, let us move on. What can I do with this? So, I have created a matrix. So, I need to perform some operations on this matrix. So, what kind of operation that I can do on a binary matrix? Okay. So, you know now that these are all binary representation. For example, Antony is represented as a binary vector along this direction, right. Brutus is represented as a binary vector along this direction. Cleopatra is represented as a binary vector along this direction. So, now we have binary values. So, now it is possible for you to perform some binary operations on this. Okay. So, in the previous slide we had shown how a binary incident matrix can be constructed for a term document corpus, right. So, now we want to find out if we can perform certain queries on this particular matrix. For example, I want to form a query Brutus and Caesar and not Calpurnia. So, I want to find the documents where Brutus is found and Caesar is found and not Calpurnia. So, the one way to do is go look at each one of those and then find out where Brutus is found and Caesar is found and not Calpurnia, right. There is one here. So, if I have a very small set of documents, I can do this in a manual fashion. Assuming I have about 1 trillion documents, I want to perform this operation, it is humanly not possible to do that. One way to do this operation is, first take the vectors Brutus, Caesar and Calpurnia and then perform the operation. So, in this case we have Brutus, Caesar and Calpurnia, and here we have asked for not Calpurnia. So, what you do is you do the not of this operation of this vector. Okay. You take the vector as is for Antony, as is for Brutus, and then complement Calpurnia and then perform the operation. Now, when you do a bitwise AND operation, what you get is 1 0 0 1 0. So, what does this represent? So, 1 represents here the document, the 0 represents this, this. The last one represents with yellow. So, by doing this operation, now I am able to perform a simple query where Brutus and Caesar and not California is found. Okay. So, in this way I can perform binary queries along the document and retrieve documents where these terms are found or not found. Okay. This is one of the examples in the information retrieval problem. So, by applying this to various other documents using binary representation, it is possible for you to do the information recovery. Okay. So, let us move on to the next one. So, now what we have seen is after tokenization, words come into play. So, the basic purpose of NLP is to identify the meaning of the word that is found in the corpus. So, what is the next step? The next logical step would be to find out how many times a particular word has occurred in a document or in a corpus. If you look at the previous case, there is no representation of the number of occurrences of a given word Antony. So, all it is saying is whether that particular word is present or absent in the given document. That is all it says. It does not say how many times it occurred and so on. So, the next operation, logical operation would be to find out how many times that particular word had occurred in a given document or in the entire corpus. So, for us to know that, we need to understand that the word is the atomic in nature for the purpose of natural language processing. Okay. So, this is the atomic unit, word is your atomic unit and that is your alphabet in the natural language processing terminology. So, we use the term as I mentioned earlier, the co-located, that they occur together or co-occurring words. They also can be considered as atomic. For example, I do not want to separate New Delhi as two different words, I want to call New Delhi as one term. So, that is atomic for this purpose of natural language processing. So, that is why I am going to be using the word term in most of the situations. So, it is not just enough if you represent the presence or absence of the word, we also want to represent it in terms of some numerical quantity. Okay. So, we want to find out what types of numerical representation a word can have. Okay. So, we will move from here to finding the word count with respect to the document, word count with respect to the corpus and so on. So, before that, a small definition here. We consider a vocabulary of size n for the corpus. V is defined as a unique set of words that you find in the entire corpus. Okay. So, this is what you find in a dictionary. So, V is nothing but my dictionary of words where no word is repeated. Okay. Some words are found in V, appear in documents collection of D1 to DM. That means, I have a set of documents which I represented as D1 to DM, and the M could vary from 1 billion to 1 trillion. Okay. Okay, let us now define our first interesting term in the statistical processing of the corpus. I will read out from this slide again. The term frequency is defined as the number of occurrences of a term Ti in a document Di belonging to a corpus D1 to Dm. So, this is denoted by Tf T comma D. Okay. So, note the suffix of these two. Okay. So, the idea is to find out how many times a particular word occurred in a given document. Suppose if the word occurred 100 times, it will be represented TFD is equal to 100 in the plain fashion. Okay. So, let us take a very small example demo where we will be finding the number of occurrences of a given term. So, this is a Python program. I am using the platform called NLTK. You will be able to find the details about what NLTK is and how you can install and how you can perform certain operations on the corpus that are found in the NLTK and so on in the internet. They are very well defined and you will be able to install it yourself on your own. Okay. So, I am using NLTK for the purpose of this demo in this slide. So, what I have done here is I have written a very small program. This program actually uses a corpus called brianstories.txt, which is available from the NLTK platform. I am going to be using a stop word removal because certain words are not very important to me for the purpose of processing. For example, the articles, the prepositions, they do not make any sense, they do not give any meaning when you want to perform certain statistical operation on the corpus. So, I want to remove them first, so that my list contains only certain vocabulary. Okay. And also I want to remove all the capitalization of the word, so that the capital word of RUN and run mean the same. Otherwise, these two will be considered as two separate words. So, in that case I need to perform the lowercase operations on all the words in the given corpus. So, for that, what I have done is I made some import classes. I am importing first the NLTK library, and then I am using the probability library of NLTK, wherein I have the frequency distribution defined. I am using the library from the corpus where stop words are defined. It should be possible for you to define your own stop words too, or add whatever is available, whatever you want to add to the existing stop words. Okay. So, first thing what I do is I am just using the corpus and get all the words in the corpus. As I mentioned earlier, right, so you do not have to really write your fundamental code in terms of tokenization. The platform does a lot of job for you. So, if you understand what exactly it does, it will be very useful to you. So, in this particular statement actually reads the corpus brianstories.txt and then tokenize each of the words and then put them in the collection words. Okay. And then I am actually looking at whether the word is alpha or not. So, there could be some numbers, there could be alphanumeric characters and so on and so forth in the given corpus. I want to only look at the English vocabulary. So, I want to find out whether a given word is an English word, then add it to my collection, otherwise I ignore them. So, this particular statement goes through the entire collection of words that we have captured in this, and then converts or creates a small subset where only the alpha words are captured. Okay. And then after capturing only the alpha word, I am going to be removing all these stop words. So, not in stop words. So, that means every word which is in this stop word will be removed, and only those which are not in this stop word collection will be added to the word count here. Okay. And then I perform a frequency distribution of all the words that I have captured in the previous instruction. Okay. So, that means my frequency distribution is again an array that contains the word and the frequencies of each of the word. Okay. And finally, what I am printing is I am printing the most common words that are found. So, I can print all of them. It is going to be a huge collection. I am restricting that to number 10 and printing them. Okay. Let us see what actually is the result. So, when I ran through the corpus, what I have got for the raw count of 10 words here. Okay. The word little appeared 597 times. Okay. And then the word came appeared 191 times. The king appeared 141 times. Okay. The day appeared 107 times. So, it is a raw count of words in the given corpus. All right. Okay. So, in this next statement running from 20 and 21, what I have done is I have made some changes to what I did earlier, right. So, earlier we only printed the word and the count. So, now I am doing some weighting on it. So, now I am printing the same thing, the word, and then but the frequency is now divided by the size of the vocabulary. So, that is the only change that I am making here. So, this is very useful in terms of normalizing the values. By providing a raw count, it does not really give me a normalized picture, whereas in this case I am adjusting the frequency to the document length. So, they get normalized. So, it gives me some additional weighted terms which I can use it for processing. So, we will talk about why we are doing it when we really perform certain operations. So, please remember that. So, we have to we can not only use the raw count as is, we can also perform some weighting on the frequencies of the words. There are multiple ways we can represent. We saw earlier that a word can be represented either as a Boolean, whether it is present or absent, represented with respect to the frequency. We can adjust it with respect to the length of the document, and we can also do the log weighting of that, so that you can convert the frequency using the given formula. So, we can represent the frequency in various ways. So, these are all the different multiple weighting factors that you can apply on the term frequency. So, what are the disadvantages of or other disadvantages of having a raw frequency? All terms are given equal importance, right. The common term the, if I had not used the stop word, will have more occurrences than any other word, but it will have no relevance to the document with respect to querying and so on. So, it may not be suitable for classification when common words appear in document. So, if the, of, and they appear so many number of times, they are not going to really help us in terms of classifying the document in a particular fashion. Okay. We move on to the next terminology that we will keep using in the natural language processing is bag of words. A bag of word is nothing but a collection of words. For example, if you have a basket and then you strip each word in a given corpus and then move it into the basket one after the other, right. So, and then when you move, what you have is only the collection of words, there is no order, nothing of that sort is available. Okay. So, that particular operation is called as creating a bag of words for a given corpus. So, this is useful when you want to perform a classification task. There is no order in the bag. You can, when you pick anything from the bag, any word that appeared in the corpus might come. It does not come in any ordered sequence. Okay. So, it represents a quantitative measurement for a given document. We create multiple bags and then shred those words from the given document and then move them into bag 1, bag 2 and bag 3 and bag 4 and so on. And then if you look at the frequencies of words in each of those bags, okay, if certain set of words appeared in bag 1 and bag 3, then we can say that bag 1 and bag 3 are somewhat related. Okay. In this way you can classify documents using the bag of words. Okay, let us move on to the next definition. This is again performed on the document. So, where we want to find the lexical variety. So, this is called as type token ratio. So, what do we do here? So, we find out what is the type with respect to the total number of words. The type is nothing but your vocabulary, the unique set of words. Okay. You have a total count of the number of words in a document, and then you have a unique set of words, right. When you create a ratio out of V and Tn, what you get is a TTR. Okay. So, this gives a very unique ratio which tells you that what is your lexical density in terms of vocabulary. For example, if you had used a very small subset of vocabulary, the value would be very small. If you used a large collection of vocabulary, then the value would be large, the TTR value would be very large. Why do we need this? It would be useful in terms of finding out how we are really improving our vocabulary on a regular basis. For example, you want to track the a child's vocabulary acquisition on a regular basis. You would be able to use this particular ratio to find out whether the child is really improving the ratio of TTR by adding more and more vocabulary to its repertoire.